So I am sharing the first topic, estimation of length of an arc. So I was explaining that if center of an arc is O and arc is AB, then arc length AB is more than the straight distance AB. Or in other words, the straight distance AB is smaller than the arc length AB. In the second figure, what is done, I have taken the same arc with same radius. Suppose earlier the radius was R, now also the radius is R, and arc is same. So I have taken a point C in the middle of the arc. Now the arc AC plus arc BC. This is the arc AB. Arc AB has two parts, arc AC and arc BC. The straight distance AC is smaller than the arc AC, and the straight distance BC is smaller than the arc BC. So their sum is less than the sum of these arcs, or you have AC plus BC is smaller than the arc AB. But AC plus BC in the triangle ABC, AC plus BC being the sum of the two sides is greater than the third side. That means the third side AB is less than this AC plus BC, and which is further less than arc AB. So what I want to say, if we want to estimate the length of the arc AB, the straight distance AB is a small value. It is not close to the arc length. But as compared to the straight distance AB, the sum of the two straight distances AC and BC is closer to the arc length AB. Though AC plus BC is still less than the arc length AB, but it is better than the distance AB. It is more than that distance AB. So it is closer to the arc length AB. Got my point? What I am going to do? We are going to estimate the length of the arc. So again, in the third figure, we have the center of the arc. Center of the arc O, and AB is the arc. Again, I take the middle point of this C, but I take the middle point of arc AC, that is D, and I take the middle point of the arc BC, that is E. So if we see the sum of the arcs AD, DC, DE, CE, and BE, this will be the full arc length AB. So I have four parts of the arc length AB: ADR plus DCR plus CER plus EBR. But if we take the straight distance AD, the straight distance AD is less than arc AD. I take the straight distance DC, add to it. DC is less than arc DC. Then I take the straight distance CE, which is less than the arc CE. And then I take the straight distance EB, that is less than the arc EB. So these four distances added, this total is less than this sum of the four arcs, but the sum of these four arcs is the arc AB total. So this sum of the four distances is less than the arc length. But again, AD plus DC, the first two terms added, in the triangle ADC, AD plus DC is more than AC. Whereas the sum of the last two terms, that is in the triangle BEC, CE plus BE, CE plus EB is more than BC. That means BC is less than the last two terms addition. So AC plus BC in comparison to the previous value AC plus BC, now we have a better estimate of the curve length. Arc length AB is still not obtained, but we have got a sum of the lengths which is still closer to the arc length AB. So earlier we were thinking of the straight distance AB, but this was very much less than the arc length AB. Then we came to the sum of the distances AC and BC. Comparatively, this is closer to the arc length AB, but still it is not equal to arc length AB. Then we have taken the four distances. Their sum is much more closer to the arc length AB, though it is still less than the arc length AB. Up to this point, what I have told, have you understood?
Sir, third वाला repeat करियो.
Okay. In the third part, like the second part, I have taken C point again, which is the middle point of the arc AB. But further, I have taken D as the midpoint of the arc AC and E as the midpoint of arc CB. Now, arc AB has got four parts: AD, DC, CE, and EB. When I put an arc at the top of two letters, then that represents an arc length. So arc length AD plus arc length DC plus arc length CE plus arc length EB. These are the total, they make arc length AB. But straight distance AD, which is shown here, straight distance AD, which is very much close to the arc AD, but still little distance is there. So AD is less than arc AD, DC is less than arc DC, CE distance is less than arc CE, and EB distance is less than the arc EB. In this way, sum of these four distances, sum of these four straight distances is less than the arc length AB. But first two terms, see, AD plus DC. AD plus DC in the triangle ADC, AD plus DC is more than AB. In other words, AC. AD plus DC is more than AC. Sum of the two sides of a triangle is more than the third. So in other words, AC is less than AD plus DC. Similarly, in the triangle BEC, sum of these two sides, CE plus EB, CE plus EB is more than BC. In other words, BC is less than the sum of these two terms. So in this way, AC plus BC is less than the sum of these four distances, which is further less than the arc length AB. But it means starting from the first, we took AB straight distance, it was less than the arc length AB. Then we took sum of two distances, two straight distances AC and BC. That sum became more than the straight distance AB, but it is still less than the arc length AB. Then we come to the sum of the four straight distances AD, DC, CE, and EB. This sum of the four distances is still less than the arc length AB, but it is still more than the previous sum of the two distances. So we are getting a better and better result for the arc length in this way. Yes. Yes, Gurman.
Sir, understand.
Arpan.
Sir, understood.
Anyone? Jasmeet?
Sir, understood.
Gurjot? Man? Mansirat?
Sir, understood.
And Sukhman? I may not be calling all the names, but anyone who has not understood, you can tell me. And even in between, it may not be when I ask only then. You can ask me anytime. So what I want to say lastly in this topic, this is only one topic for today. There are more, but this is the main thing. If we make 8 parts of the arc AB, then the sum of the 8 straight distances, we can show like this. We will not actually take the calculation, but it is understood now. Suppose these points are P, Q, R, and S. So if we try to find the sum of the distances AP plus PD plus like this, sum of 8 distances, it will be slightly less than the arc length AB, you can understand. But it will be still better result than the sum of these 4 distances. Okay.
Sir, yes.
So what I want to ask one thing now, if you have got it clear, if we make 1,000 such parts of arc length AB and 1,000 straight distances if we add, will that not be almost the same as the arc length? From the picture you can see just we have done 4 parts and there is not much difference between the sum of these 4 straight distances and the arc lengths. Not much difference is there. You can see if we will be doing 8 parts, this difference between the sum of the 8 distances and the actual arc length AB will be so small that it may not be visible to the eye. You can see it, the distance, the difference with the lens. But if you are making say 256 parts or 1024 parts or 1 lakh parts, what will happen? You may not be able to judge the difference even with the help of a microscope. And what about if we make infinite parts? What if we make infinite parts? Sum of all these distances won't be exactly equal to the arc length. Can this idea comes to your mind? Jasmeet, Anmol, does this idea come to your mind that if there are say million parts, we make million parts of the arc AB and we add the million straight distances, then the sum of those distances will be hardly different from the actual arc length? Hardly means there may be some difference, but that difference will not be judged by the microscopes, best microscopes. And what about if we make infinite parts? On an arc or on a circle, we can think there are infinitely many points. If you make infinite parts of this arc, and if you are able to add, and actually in the calculus we do this thing, we add the infinitely many things. This is what I am telling, the introduction part of the calculus to be used in +1 and +2. So do you feel this thing that if you will make infinite parts of the arc length AB and if you add infinite straight distances, each will be very small, very small distance, but very small distances, if we add infinite times, the arc length AB will be obtained. Are you getting my point? Man,
Sir, please repeat it.
are you able to understand this? Ki AD is slightly different from straight distance. AD is slightly different from the arc AD.
Sir, yes.
And that's why I wanted to know, actually I am working on the laptop screen and you are watching the class, these images or this on your mobile. On your mobile screen, are you able to see the AD arc and AD distance, straight distance has a gap in between them? So that's why
Sir, yes.
I had given the message in the group. Whatever I write, is that visible? Like I have written estimation of length of an arc. Is it, I am seeing it on the laptop, but are you able to read the words on the mobile?
Sir, yes.
So what we see, the gap between arc AD and straight distance AD is there, but very small gap is there. Similarly, CD arc and CD straight distance, CE arc and CE straight distance, and EV arc and EV straight distance. If we add these four straight distances, these will be slightly less than the sum of the four arcs. And sum of the four arcs is, because these four arcs are the four parts of the arc AB, their total will be arc AB. And therefore sum of these four distances, just four distances, is very near to the actual arc length. What will happen if we make 8 parts and add the 8 straight distances? Maybe it happen. My eyes are not very good, having very good sight, but if the eyesight is very good, normal, like you have, then 8 parts may also have some gap visible to you. But if I make 16 parts on, or I make 32 parts or 64 parts, what I am doing, each time I am increasing the parts twice. First, I had taken only one part, AB. Then I have taken double of that, 2 parts. Now I have taken 4 parts. If I take in this way, in the powers of 2, 4, 8, 16, 32, 64, 128 parts if I take, will you be able to see the gap between those small 128 distances and the corresponding arcs which are small? Not, you won't be able to see, right? Because gap is regularly, continuously getting decreased. As we are increasing the number of parts, the gap between the straight distance and the arc is getting smaller and smaller. And what happens if we make infinite parts? The gap will be absolutely zero. The sum of those infinitely many distances will be the same as the arc length. This is what I want to say. If you understand this thing, then if you really understand this thing, everyone say yes, then it means we can proceed ahead.
Sir, yes.
Sir, yes.
Anyone who says no, please. Sukman, Mansirat, are you there? Khushpreet,
Sir, yes.
okay, Gurman,
Sir, yes.
Jasmeet,
Yes, sir.
Anmol.
Yes, sir.
So now I can proceed further. I am stopping the sharing, going to the next page. Should I do this, or I think I should skip this part? I should straight away go to the third page. Yes, that is better. I will try to, actually the most difficult part as far as understanding was concerned is over now. Rest is simple maths now, simple geometry. So I am going to share I hope this is now, is it visible? Constancy of the ratio of circumference of circle to diameter. Is this visible?
Yes, sir.
Anybody who knows what is the ratio of the circumference to the diameter of the circle known as? Circumference of a circle divided by the diameter of the circle. What is this ratio known as? Yes. This is pi. Because circumference is pi times diameter. Because diameter is twice of the radius. So circumference is pi times 2r, that is 2 pi r. This is the formula for the circumference.
So yes.
But who told this thing? Ki circumference of any circle, whether small or large, any circle, the circumference of any circle divided by the diameter of that circle is always constant. It may happen ki for smaller circle, the ratio of the circumference to the diameter is different. For the larger circle, the ratio of the circumference to the diameter is different. Who knows? Who proved it? Yeah, how is it proved that the ratio of the circumference to the diameter is constant? So this is actually proven like this by the same concept. Suppose actually I have made here 16 parts. I have made 16 parts in the smaller circle as well as in the larger circle. And these 16 parts in both circles have equal vertical angles. So all these parts of one circle are congruent to each other, and the 16 parts of the larger circles are congruent to each other. What happens if I take any one part? Suppose I have chosen this part and I join this by the straight distance. Observe, is there much difference between the straight distance which is shown red and the earlier blue arc? Is there any gap visible to you? Though blue arc is being seen separate, red straight distance is being seen separate, but gap is not visible. It may be because the width is there. The pencil with the help of which I am drawing the straight distance, or with which I have drawn the arc, that also have the width. But it is clear that if we make infinite parts of the circle, the distance, straight distance and the arc will be coinciding with each other. This is I have explained. Okay. So suppose that the circumference of the smaller circle is C and the larger circle has the circumference C dash. Suppose I make n equal parts of the circumference, then the arc length will be C divided by n. I have made the n equal parts of the circumference. So what happens? Each arc length will be equal to C by n for the smaller circle, and for the larger circle I have also made n parts, actually in the figure 16, but I am using the idea I have made n parts. So larger circle has the larger circumference, suppose C dash, and that divided by the number n, that is the length of this arc, where the straight distance is this one. Is that clear? Yes.
Sir,
Okay.
yes.
Now this has got radius r, and this has got radius, suppose capital R. This arc length I am going to take equal to the side of this triangle. What I have said earlier, this side length, the straight distance is just, you can understand that this is equal to the arc length, because for very large number of parts, the straight distance and the arc length are equal. So suppose that this straight distance is B, that is equal to the arc length, which is C by N. And here this straight distance is suppose capital B, that is equal to C dash divided by N. Now, here all radii are equal to small r, here all radii are equal to capital R. What is this angle? If I use the modern notation, which is though not essential, let us use the old notation. Complete angle is 360 degree. And if we have divided that into n equal parts, so this angle is equal to 360 divided by n. This angle, this is a simple geometry. I have divided the complete angle 360 degree into n equal parts. So this part is, this angle is how much? 360 degree divided by n. But same way I have made n equal parts of 360 degree here also. So here this angle is also the same. So suppose this angle is theta, this angle is also theta. If I name this triangle as OAB and I name this triangle as O dash A dash B dash, are these two triangles similar? Triangle OAB is similar to triangle O dash A dash B dash. If you clear to anyone, please let me know why. What criteria of similarity? See, the ratio of the side OB to the side OB dash is equal to small r by capital R, which is the same as the ratio of the side OA to the side OA O dash A dash. So two corresponding sides have the same ratio and the included angle is same. So these triangles are similar. SAS similarity. Okay. Yes. Is this point clear? Are these two triangles similar? Yes, Anmol, Jasmeet, yes, what are you saying? Is it clear? Then
Sir, yes.
what will happen? The third side will also have the same ratio. AB divided by A dash B dash will also be equal to this ratio. The third sides will also have the same ratio. And we are just near the result now. AB, what we have? If we have taken the circumference of the small circle as C and we have made n equal parts, then arc AB is equal to C by n in length. And the side of the triangle AB is also equal to that. Because we are making very large number n of parts of the circle. So arc and the straight distance AB are just equal, we are taking. So AB is how much? AB is equal to C by N. And this divided by A dash B dash. A dash B dash is just equal to the arc A dash B dash, which is, if the circumference of the larger circle C is C dash, we have made n equal parts of that, then arc length A dash B dash is C dash by n. And straight distance, that is the side of the triangle, A dash B dash is just the same. So C dash divided by n. N cancels here. So what we get? But we get that the ratio of the circumference of the smaller circle to the circumference of the larger circle is equal to the ratio of the smaller radius to the larger radius. And from this we get the result. If we take small r below the C and take C dash above the capital R, we can write the ratio like this. If we multiply the denominator by 2, twice r is the diameter. So for the smaller circle, circumference divided by the diameter, circumference divided by the diameter for the smaller circle is same as the circumference divided by the diameter for the larger circle. So that means circumference divided by the diameter is constant. This is constant, and this constant is called, this constant is named as pi. I hope this is clear.
Yes, sir.
So that is the things like this. In calculus, we make the infinite parts of something and we add those parts. Such things we do in calculus. This is the most basic idea we are using here in the basic formula of circles. From here, actually, we get the formula this. Circumference is equal to pi times diameter, and diameter obviously is twice of radius. So we get circumference is equal to pi times twice r, and that is 2 pi r. So I hope this is clear. Okay. So can I close the class here? So tomorrow we will be doing, wait for a minute, let me take the attendance. Tomorrow we will be doing the area of circle. Yes. So now we can leave the class.